So the next question is, observe the following equilibrium. Fe plus 3 aqueous plus SCN minus aqueous is equilibrium with Fe SCN plus 2. So aqueous. It is yellow in color. Fe plus 3 SCN minus is colorless. After these two reacts with each other forms deep red colored solution. So next, addition of aqueous oxalic acid solution to this above equilibrium. If you add oxalic acid solution to this equilibrium, which of the following is correct one? So if you add oxalic acid solution to this equilibrium solution, Fe plus 3 reacts with oxalic acid solution. That means when oxalic acid reacts with Fe plus 3 moles are decreases. So according to Le Chatelier principle, when Fe plus 3 number of moles decreases, the reaction shifts left side and Fe plus 3 is formed. That means it is decomposed and forms Fe plus 3 according to Le Chatelier principle. So that means deep red color intensity decreases when the reaction shifts left side, equilibrium shifts left side. This deep red color intensity slowly decreases. So which one option is correct? Shift the equilibrium towards the formation Fe is SCN twice. Here first option is the equilibrium shifts towards right side, so that is wrong. Equilibrium shifts towards left side, that is correct. So first option wrong. Second option, deep red color increases. Deep red color intensity decreases. So second option also wrong. Intensity of deep red color decreases. So correct one. So third option correct. No change in equilibrium. So it is wrong. So option C is correct. Because oxalic acid solution reacts with Fe plus 3, then equilibrium shifts backward direction. So backward direction. So answer is C. Okay, next question. At T kelvins, the Kp for the reaction A2B6 is equilibrium with A2B4 plus B2 is 0.04. So Kp is 0.04 atmospheres. The equilibrium pressure of A2B6 when it is placed in a flask at 4 atmospheric pressure and allowed to come to above equilibrium is. So first the given A2B6 is equilibrium with A2B4 plus B2 gas. So what is the atmospheric pressure? First flask at 4 atmospheric pressure, 4 0 0. At equilibrium it is 4 minus x x. So Kp is 0.04. What is the Kp formula? Kp is equal to A2B4 pressure of A2B4 into pressure of B2 by pressure of A2B6. So that is equal to pressure of A2B4. That means x into x by 4 minus x. That is equal to x square by 4 minus x. What is the Kp value here? 0.04. 0.04 equal to x square by 4 minus x. That implies x square by 4 minus x is equal to 0.04. X square is equal to, if it is multiplying with 0.04, 0.16 minus 0.04x, x square plus 0.04x minus 0.16 is equal to 0. If you calculate factors for this reaction by using formula minus b plus or minus square root of b square minus 4ac by 2a. By using this formula, if you calculate the factors and x value is, if you finally find out 0.38, I already calculated. So x is equal to 0.38. X is equal to 0.38 means A2B4, x is equal to 0.38 means A2B4 0.38, B2 value 0.38. But he asked allowed to come the equilibrium pressure of A2B6. So this value equilibrium pressure of A2B6 is equal to 4 minus x. So 4 minus 0.38. So that means 4 minus 0.3. So here options are 0.362, 3.62, 3.4.36, 0.46. So answer is 3.62. Okay, not this. Okay, see the next question. For a reaction, A plus half mole of B is equilibrium with C and it releases heat. So what are the favorable conditions for forward reaction is? First, the reaction exothermic or endothermic. How do you find which the reaction, the given reaction is exothermic or endothermic without giving? It releases heat. Heat releases means exothermic. Heat absorption means endothermic. After the reaction plus the given heat, that means heat releases. So it is exothermic reaction. So exothermic reaction. So for exothermic reactions, low temperature required. For any exothermic reaction, no need to require temperature. For this reaction, favorable conditions are low temperature required. So low temperature. So and high pressure or low pressure. How do you find how much pressure? High pressure or low pressure required? Reaction here 1 mole plus half mole. That means 3/2 moles. In reactant side 3/2 moles. 3/2 moles are converted to 1 mole. So that means volume decreases. Volume decreases means pressure increases. So volume decreases means pressure increases. That's why for exothermic reaction low temperature required and high pressure required. Low temperature and high pressure. So answer B. Very easy. If here is heat is there, then that is endothermic reaction. Plus heat here, that is endothermic. Next question. Which are the following correct relationship for this reaction? 2 moles of A is converted to 1 mole of B plus 1 mole of C. So for this reaction, what is the delta N value? Delta N means number of moles of gaseous products. Number of moles of gaseous products minus number of moles of gaseous reactants. How many number of moles of gaseous products? It is 1 mole, it is 1 mole. 2 moles minus here 2 moles. So 2 minus 2 is equal to 0. If delta N is equal to 0, then Kp is equal to Kc. So answer D. If delta N greater than 0, then Kp greater than Kc. If delta N less than 0, then Kp less than Kc. Very easy. So next, 9th one. Which of the following statement is true when equilibrium is established in this reaction? This reaction is given at Kc is equal to 10. So first you write A plus B is equilibrium with C plus D. Kc is equal to 10. So what is Kc? How do you write Kc? Kc means the product of concentrations of products by product of concentrations of reactants ratio. So concentration of C into concentration of D by concentration of A into concentration of B. Next, if it is come to here, concentration of A into concentration of B equal to 1 by Kc into concentration of C into concentration of D. So concentrations of A and B is equal to 1 by Kc means 1 by 10 into concentration of C into concentration of D. So concentrations of A into B is equal to 1 by 10 means 0.1 into concentration of C into concentration of D. So option C is correct. A into B is equal to 0.1 into C into D. Okay, not this. See the next question. For the gaseous reactions 1 and 2, two reactions are given. So the equilibrium constants are x and y respectively. Its equilibrium constant is x, its equilibrium constant is y. So using the above reactions, the equilibrium constant Z for the reaction 3 given below. For this reaction, You calculate equilibrium constant by using these two reactions. Very, very, very easy. So first we want this reaction from these two reactions. In this reaction, N2O4 is left side. So for this reaction, N2O4 right side. So if it is converted to reversible reaction, that means equation 2 can be written as reverse reaction. So N2O4, so for this reaction, reverse reaction, N2O4 is equilibrium with 2NO2. For reverse reaction, Kc is 1 by Y. For this reaction, Kc is Y. For reverse reaction, Kc is equal to 1 by Y. Reciprocal. So next, it is equation 2. Equation 1, here, how many moles of N2 is there? 1 mole. For this reaction, 1 mole of N2, 2 moles of O2. But for this reaction, half mole of N2, half mole of O2. And also in this reaction, it is N2 and O2 are present left side, reactant side. But in this reaction, N2 and O2 are present product side. Again, equation 1, reverse reaction. And it is multiplying with 2 into 2. Then 2 into 1 by 2. 2 into 1 by 2 and reverse. 2NO2. 2 into NO2, 2NO2. Understand? For this reverse reaction, we multiplying with 2. So 2NO2. 2 into 1 by 2 N2 means N2 plus 2O2. These are gases. So for this reaction, Kc is equal to, first for this reversible reaction, Kc is equal to 1 by X. It is multiplying with 2 means this 2 came to power 1 by X power 2. Understand? If 2 moles are there, 1 by X power 2. If 3 moles are there, 1 by X power 3. So then adding of two reactions, adding of above two reactions. So then 2NO2 cancel. N2O4 is equilibrium with N2 plus 2O2. So then Kc is equal to, when you add reactants and products, these two reactions, these Kc values are multiplying with each other. That means product, you have to take product of two Kc values. Then 1 by Y into 1 by X whole square, 1 by Y into X square. So Kc is equal to 1 by Y into X square. So answer D, 1 by X square Y. Very easy. So next, at T kelvins, the equilibrium constant of H2 plus I2 is equilibrium with 2Hi is 49. Equilibrium constant is given 49. If H2 I2 at equilibrium at the same temperature, that means H2 concentration, I2 concentrations are given. The Hi concentration at equilibrium. So first you write H2 plus I2 is equilibrium with 2Hi. For this reaction, Kc is equal to product Hi concentration whole square, 2 moles means power 2 by, it is 1 mole. So H2 concentration into I2 concentration. But we want Hi concentration. Its value is given, I2 concentration value is given, Kc value is given. So for that implies Hi whole square equal to Kc into H2 into I2. So Kc value 49. H2 concentration is 2 into 10 power minus 2. I2 concentration 8 into 10 power minus 2. Okay. So that implies Hi concentration whole square is equal to 10 power minus 2 to 10 power minus 2, 10 power minus 4. So 49 into 2, 49 into 2, 98, 98 into 8, 98 into 8, 784. So that implies Hi concentration is equal to square root of 784 into 10 power minus 4. So its value is 28 whole square 784, 28 into 10 power minus 2. So answer 0.28. Okay, note this, very easy. Let's see the next question. For a given equilibrium reaction, addition of an inert gas at constant volume can shift the equilibrium. The reaction is N2 plus 3H2 is equilibrium with 2NH3. So see the given table. At constant volume, at constant pressure, if delta N equal to 0 or greater than 0 or less than 0, at constant volume has no effect. But at constant pressure, delta N equal to 0, no effect. Delta N greater than 0, forward direction. Delta N less than 0, backward direction. So in the given question, at constant volume, so at constant volume, it is independent on delta N. So it has no effect. So next, for the reaction 0.5 C plus 0.5 CO2 is equilibrium with CO. The equilibrium pressure is 12 atmosphere. If CO2 conversion is 50%, the value of Kp in atmospheres is. So you observe the reaction 0.5 moles of C plus 0.5 moles of CO2 gives 1 mole of CO. Here 50% CO2 consumed. That means in 0.5 50% means 0.25. So Kp is equal to pressure of products by partial pressure of products by partial pressure of reactants. That is equal to partial pressure of product is 1 by 0.25. So the value is 4. So okay, thank you.